Are you wondering whether quantum computers can break blockchain? Are systems like Bitcoin and Ethereum in danger in the future? Let's explain this topic in a super simple way, so everyone can understand it. First, why is blockchain so secure today? It all comes down to encryption keys. Your Bitcoin or Ethereum wallet actually has a public address and a private key. This private key is like the solution to an extremely complex mathematical puzzle. Even if today's normal computers tried trillions of combinations, finding this key would still be almost impossible. That's why hackers can't steal your private key and take your money. In short, with today's technology, blockchain encryption is solid like a rock. So how do quantum computers change this equation? A quantum computer works completely differently from the laptops or supercomputers we use today. Normal computers use bits, zeros and ones, and they evaluate only one possibility at a time. Quantum computers use special particles called qubits. A qubit can represent both 0 and 1 at the same time. Because of this, a quantum computer can calculate millions of possibilities simultaneously. In theory, a powerful enough quantum computer could solve blockchain's complex mathematical puzzle extremely fast. It could find a private key in seconds, which would completely break blockchain security. That sounds scary, right? But what is the real situation today? Now let's get to the most important part. How powerful are today's quantum computers really? Big technology companies like IBM, Google, and Microsoft have been developing quantum computers for years. IBM even provides quantum machines that you can access through the cloud. This is amazing for scientific research, but it is absolutely not enough to hack a blockchain network. A 100-qubit machine is a serious scientific tool, but not a hacker's weapon. So why isn't it enough? Because the biggest problem with quantum computers today is instability and high error rates. Qubits are extremely sensitive. Even tiny vibrations, temperature changes, or magnetic fields can disrupt their calculations. This problem is called decoherence. You may start a calculation, but errors prevent the qubits from finishing it correctly. To break blockchain, you don't just need many qubits. You need qubits that can work correctly for a long time. These are called logical qubits. IBM'in gelecek planlarına baktığımızda binlerce, hatta 10 binlerce qubit'e sahip sistemler hedeflediğini görüyoruz. Looking at IBM's future plans, they aim to build systems with thousands or even tens of thousands of qubits. Projects known as Starling and Blue Jay are not only about increasing qubit numbers, but also about allowing systems to correct their own errors. This would enable billions of operations to run reliably. But this is far beyond today's technology. Other companies are also working on this. Microsoft is developing a different type of qubit called a topological qubit, which is expected to naturally reduce errors. Google is also competing with its own 105-qubit chip. However, all current prototypes are still experimental, unstable, and unable to run complex calculations for long periods. So the fear that quantum computers already exist, therefore blockchain will be broken, is simply not true today. Today's quantum computers do not pose a real threat to blockchain security. It is like trying to go to the moon with a bicycle. You technically have a vehicle, but it's not powerful enough for the mission. To break blockchain, you would need millions of stable, error-free qubits. Today, we are only at the hundreds level, and those qubits are still very noisy and unreliable. So what about the future? What happens if quantum computers really become that powerful one day? There's no need to panic. Scientists are already working on solutions. This field is called post-quantum cryptography. It means developing new encryption methods that even quantum computers cannot break. In the future, new security standards will protect systems against quantum attacks. Bitcoin, Ethereum, and other blockchain projects can migrate to these stronger cryptographic systems when the time comes. It's like an arms race. When one side builds a stronger weapon, the other side builds a stronger shield. Let's summarize everything in a very simple way. First, today's quantum computers are nowhere near powerful or stable enough to break blockchain. Blockchain networks are safe for now. I second. In the future, maybe in 10 or 20 years, quantum computers could theoretically reach that level of power. But third, and most importantly, the cryptography world is not unprepared. Quantum-resistant security systems are already being developed. So blockchain technology will evolve and protect itself against future threats. For now, you can breathe easy. We will continue to follow these developments. If you found this video helpful, don't forget to like and subscribe. See you in the next video. Goodbye.